Dear students, in today's module, we will be discussing two things. One is the direct memory access and the other is handshaking. So in the previous module, we have learned about controllers. As the controller is directly attached to the bus, so that controller can communicate directly with the main memory. So for example, if there is something in the main memory that need to be transferred from one location to another location, or there is some data on peripheral devices that need to be transferred to the main memory, or there is something on the main memory that need to be transferred outside to the peripheral devices, so controller could help us by directly accessing the memory, the main memory. So this ability of computer to access main memory directly is known as direct memory access. Why we need direct memory access? So it is very time consuming for central processing unit that it communicate with the I/O. So you know that our CPUs are very efficient. They are performing billion of instructions in 1 second. So if they want to write something on the printer, so they cannot wait for the printer to write each and everything and then they come back. So in such a situation, controller can help us to communicate properly and to take such a task on its own and doing it by itself to let the CPU free so that CPU can do some other task in the same time. So to involve CPU for I/O, and CPU is waiting for the I/O and supervising whether the I/O has been performed or not. So here is a scenario. So for example, CPU asks controller to read data from one peripheral device or from one portion of the main memory to another portion of the main memory. So it can read, it can do this task, and in the meanwhile CPU is free, and in such a time CPU can perform other functionalities so that the overall throughput of the system could be increased. So it would be resource efficient. So here is a scenario which we can see on this slide. So for example, we have a CPU, main memory. You know there is a bus which we have already discussed in one of the previous modules that is connecting CPU with the main memory, and then there is a controller available here for all of the devices. So for example, CPU asks any controller like this controller to perform certain tasks of input and output using this bus. So the controller can use this bus for such a time slot when this bus is not being used by the CPU. However, if the same bus is being used by the CPU and the controller, then we will have a problem. And such a problem is known as von Neumann bottleneck. So in fact, CPU is connected with the main memory using the same bus, and the controller is also utilizing the same bus. So in the von Neumann architecture, it was mentioned that there is a central bus and everything like the CPU, main memory and all of your controllers will be connected to that bus. So if CPU and controller are competing themselves that they should get the access to this bus, then such a problem would be known as bottleneck, because someone have to wait until other can complete his work. So each controller and main memory and CPU and controller are competing for the bus access. So the next topic is handshaking. So you know that CPU want to send data to the printer. So suppose, as we have mentioned, that the speed of the CPU is very efficient. We can process billion of instructions in 1 second. However, the speed of printer to printing is not so efficient. So if CPU keeps sending data and printer is not able to printing that data with the same speed, as it would not be able to do it anyway. So in such a situation, we will have a problem. So we follow, our computer science follow a handshaking strategy. In handshaking strategy, every device is telling back to the CPU that please wait, I am in the position to printing the previous content and you should not send me the next content until I am free. So that is being done on regular basis. And for example, in the case of printer, it is telling you that there is a paper jam. For example, I have finished the work out of the paper, etc. So such information is being communicated by the device. So that device is handshaking with the CPU with the help of course, controller. So if we summarize today's module, we have learned two important concepts. One is direct memory access using the controller because it has the direct access to the main memory. And then we have seen that there are certain benefits of it as CPU is free in such a situation for such a time slot. However, there is a well-known issue that is known as von Neumann bottleneck, which should be avoided. And then we also learned the process of handshaking.